In the transmitter of a digital communication system, the digital modulator converts the information bits in a signal that is transmitted through the analog channel. At the receiver, the digital modulator must convert the received signal, the signal at the output of the channel, into a sequence of bits, trying to recover the transmitted information. In this video, we will analyze the behavior of this digital demodulator. And the demodulator must process the signal that is at the output of the channel to try to recover the information that was transmitted. It must estimate the binary sequence that was transmitted. And the problem is that the received signal is not equal to the transmitted one, because distortion happens during the transmission. The processing of the received signal is piecewise. The time is split in intervals associated to every symbol, and the signal in each interval is processed to try to recover the symbol, the block of n bits that was transmitted in this interval. To estimate the nth symbol, the observation interval is the symbol interval for this symbol, which is the range between n times the symbol time duration and n plus 1 times the symbol time duration. The signal in this interval is compared with the n possible waveforms that were transmitted in the modulator, with the n waveforms associated to the n possible symbols. If the closest match is the signal with index j, the estimated symbol is the symbol with index j. Here we have an example for a 480 system. We have 2 bits per symbol, 4 possible symbols, B0, which is 0, 0, B1, which is 0, 1, B2, which is 1, 0, and B3, which is 1, 1. And here we have the signals S0, S1, S2, and S3 that were used in the modulator to transport B0, B1, B2, and B3 respectively. If this is the received signal, the time is split in symbol intervals. In intervals of duration, the symbol duration time, capital T. And then each piece of this signal, the piece that is in the different symbol intervals, will be processed independently to recover every symbol. If we start with the first symbol interval, the signal that is in interval is compared with the 4 possible transmitted signals, S0, S1, S2, and S3. In this case, the most similar one looks to be S1. This means that the estimate of the first symbol is the symbol B1. Then the second symbol interval is analyzed. This signal is compared with the 4 possible transmitted signals in this interval, and this seems to be more similar to S3 than to any other waveform, and this means that the estimate for the second transmitted symbol is B3, the symbol associated to signal S3. And this process is repeated for every symbol interval. In the third interval, we have this signal. If this signal is compared with the 4 possible transmitted signals, in this case, it looks that the most similar signal is S2, and this means that the third symbol is estimated as the symbol B2, the one associated to the signal S2. In the next interval, this signal is compared. The most similar signal is S0. In the next interval, the most similar signal is S3. In the last interval in this example, the most similar signal is S1, and the last estimates for the symbols are B0, B3, and B1 respectively. Finally, once that we have the estimate for the symbol sequence, we have a symbol to bit conversion. Every symbol will be converted in this example in a pair of bits. B1 is converted in 01, B3 is converted in 11, and this process is repeated for every transmitted symbol, for every estimated symbol. If the digital modulation at the transmitter employed a different set of 4 signals, for instance, these ones, the signals are different, the signals that must be compared with the observation in any interval are different, but the procedure is the same one. If we have the first interval, this signal is compared with the 4 possible transmitted sequences. The most similar one is S1, so the first decision is symbol equal to B1. This is straightforward.